Good morning and welcome. My name is Mahesh Senagala. I am Chair of Architecture Department at Ball State University and also the co-chair along with Noha El-Gobhashi and Shekhar Chandrasekhar. And I'm very pleased to welcome you all, both in here and out there on the web, those of you who are following us online. We have a very exciting program and a very rare confluence of people from different disciplines coming together here to talk about some of the biggest challenges that we are faced with and going to be faced with soon and in the future. And the workshop has been funded by National Science Foundation, and we are hoping that our discussions will lead to making further inroads into restructuring and creating new ways of supporting research to address the issues of materials and manufacturing for extreme affordability. And as someone who in early 60s and 70s been part of the base of the pyramid in India, I personally know very well what it is like to be part of that base. And so this particular topic is very dear to my heart, and I'm very pleased to find resonance across the disciplinary boundaries and to bring you all together here. And without much further ado, I would like to invite Provost and Vice President for Academic Affairs, Terry King, to welcome you all to Ball State University.
Thank you, Mahesh, and good morning and welcome to Ball State. It is always particularly pleasurable for me to welcome an event in which professionals connect, collaborate, and even challenge one another. As an engineer, I always enjoy workshops in which industry experts share their knowledge about theory, research, and practice. And as an educator, I'm especially pleased and grateful to see the opportunities for learning you provide, not only with your knowledge and experience, but also with your professionalism and dedication to craft. And as an engineering educator at a university with no engineering program, I'm especially pleased to welcome my fellow engineers. It gets a little lonely here sometimes, although I do love my architect friends. I want to take a moment to thank the workshop organizers. They've done a fabulous job. Conferences are worth all the hard work, but make no mistake, it is hard work. I also want to thank all of you for taking the time out of your busy professional and personal lives to come to Ball State. We think we are a very special place, but we know we're not always easy to get to. And speaking of traveling to get here, the conference participation list is certainly impressive, representing at least 4 countries, 10 states, and certainly people from around the world. This 2-day workshop focuses on addressing the needs of the base of the pyramid. That's a noble but daunting task. Google estimates 11 million hits on the phrase base of the pyramid, or BOP, and most sources estimate the population of that base to be around 2.5 billion. You may know better than I. It is the largest but poorest socioeconomic group. Historically, the base of the pyramid has been the focus of business and politics. One of the most recent foci has been the impact of the base of the pyramid on sustainable environments. The base should also be, as is evidenced by your presence today, a focus of education and scholarship. And while alternative spring breaks and service learning opportunities are important for our students, the focus should be much broader and much deeper. As I read about this conference and your work, several themes emerge. You are explorers and innovators. You are entrepreneurs. You are global in your thinking and local in your action. You are collaborators, and your collaboration empowers others. Moreover, you do all this with a sense of great moral obligations to those you serve and to each other. Ball State's strategic plan and your conference mesh very well. We, too, seek to foster and support activities of faculty and students that have the potential to lead to enterprising ventures. We seek best practices and the innovative use of technology. We consistently try to improve the university community's quality of life. We address local, state, national, international needs, and we seek to do all this in a sustainable manner. Chris Bull noted that engineers must be skilled at working in teams across disciplines and with diverse groups, and we agree and would add that all disciplines benefit from this approach. That is why Ball State is redefining education by emphasizing immersive learning and interdisciplinary approaches to solve real-world problems. Wes Jans has asked you to consider who the 2.5 billion people at the base of the pyramid are. We were reminded in horrifying fashion last week in Japan that circumstances could force any of us down that pyramid at any time. We were reminded of the importance of solid foundations, both literal and metaphorical. Your research in materials and manufacturing is of critical importance, and I am honored that you are here. I wish you all an invigorating and successful workshop. Thank you.
Thank you, Provost King, for those inspiring remarks. And I would like to now invite Dean of the College of Architecture and Planning, Guillermo Vasquez de Velasco, to welcome you all.
Thank you, Mahesh. Good morning. I also want to welcome you, everyone in this room, and also those that joined us as a global audience through the networks. It is a real pleasure to have you here with us. Welcome to the College of Architecture and Planning. Welcome to the CAP. The College of Architecture and Planning at Ball State University is an institution deeply committed to the project of a better world. A world where design makes a difference not only in the lives of a few, but in the life of everyone. We believe that the power of design can help us address the very urgent needs of those at the bottom of the pyramid. We believe that the power of design can change lives. We also believe in the need of thinking global, and obviously we're doing that. We understand the need for bridging between the silos to be multidisciplinary. Again, obviously we're doing that. And we understand the need to continue to learn. We are perpetual learners, and we are all here to learn from each other. I know that we all share those beliefs. Last but of course not least, we're also true believers in the need to be sustainable. In that context, we know that addressing the needs of the base of the pyramid through charity and philanthropy is not sustainable. Design for extreme affordability makes good sense, makes financial sense, and it may be our best opportunity for global sustainable development. We are trying to address a great challenge here today, but I think that the opportunity is even greater. I have spent half of my life, the first half, in Lima, Peru. I'm very familiar with how the base of the pyramid looks and behaves. I think it's critical for us to start looking in that direction. And I want to thank our organizers for the hard work of putting together this event. As Provost King mentioned, it is hard work to put an event like this together with such a wonderful, awesome group of design thinkers. So as someone that deeply understands the challenge and the opportunity that you will be addressing, I want to thank you very much for coming and for, I hope, the next 2 days of important deliberations and, of course, a lot of learning. Thank you very much for coming, and welcome to the CAP.
Thank you, Guillermo. And as I mentioned, the workshop has been sponsored by National Science Foundation. But really the effort of bringing this together, the credit goes to my collaborators from ASME and IEEE and Engineering for Change. I would like to now invite Dr. Chandrasekhar from ASME and Engineering for Change, and welcome you all from those organizations.
Thanks, Mahesh. You know, I was thinking, what do I really say? I had three options. One, I would tell you a story. But if I do tell you a story, I know some of my esteemed colleagues will bring a baton and chase me out of here. So I said, nah, can't tell me a story. Then I said, I'll take out my notebook and read a speech 10 pages long. Then I'll figure everybody might go to sleep. So I said, you know, third option is the best. Speak from your heart. Growing up in India, this is tremendously, it's a very powerful thing that we are doing today. And I'm honored and humbled that at this audience of esteemed scientists, engineers, architects, that I'm speaking a few words. I want to thank Ball State and NSF for giving us this opportunity to put this together. And I want to thank each and every one of you who have come from all parts of the globe to this conference. A common theme is emerging. It's the nexus of so many disciplines: engineering, architecture, social science, NGOs. And what's amazing is we are here to collectively bring these thoughts, to solve a problem, to even identify this problem, let alone solve it, shape it, and give it life. ASME, IEEE, Engineering for Change, has made a deliberate effort, committed a lot of resources to kind of work with academic institutions, corporations, businesses, to kind of foster this community building, nurture this network. And I'm hoping that this engagement that you see here today is kind of the first step. Let's visualize when Neil Armstrong went to the moon and he said, this was a small step for man, but a giant leap for mankind. My vision of all of this, and I'm hoping that you participate in this is the first step. Let's fast forward this clock 50 years from today. And as you start to think through what are the innovations, the rewards, just imagine if somebody got a Nobel Prize in something that they did and looked back on this event as the trigger for everything that happened. How powerful would that message be? So as I'm sitting back and I'm thinking through some of this stuff, I am so excited. I really, really am from the bottom of my heart. And to the audience who are ASME, and people have spent a lot of time and resources, Ball State resources. There are people like Angeline and Nora sitting back in New York City, Madhu, Yana, Gretchen, who have also put in their time, John Falcione, who's going to be moderating. But I'd really like to speak about one individual, an individual who kind of embodies what is represented by the space. Some of you may have met this individual already. And if I think of all of what the space embodies, I can capture this as the 3 Ps and the 3 Ds. First P is persuasion. I mean, second is persistence. And third is pursuit for progress. You really need those qualities as you start to think through and do this stuff. You take those concepts and add it to dedication, devotion, and drive. You get a powerful team of people who not only are able to kind of identify the problem, create something out of it, and give it life. And as I look at this audience, read the white papers, looked at the 2020s, it just became so obvious. However, what I want to do is to identify one individual who possesses all of these qualities. Ms. Noha Al-Gawashi, who actually many months ago started this concept in the embryonic stage and worked with Mahesh and I, and Mahesh will agree with some of this, to not only kind of take this embryonic concept to something more tangible, but also engage this audience. And that's a very powerful thing to do. Thank you, Noha. And also on a personal note, thank you for engaging me in this. But before I sign off, before I kind of step back, all of you, I want you to think of something so dear to my heart. And I want to take you to a book by James Collins. James Collins has written many books, a management guru. But there are two books that really stand out. One is Good to Great, and one is Built to, I believe it's called Built to Last. And in those two books, he introduced a concept called BHAG. BHAG really stands for, just to complete this story, big, hairy, audacious goals. And a lot of corporations really embodied what this stood for. They embraced this and kind of transformed themselves from point A to point B. So before I sign off, to the audience who are listening on the web, to people at the back, I want to leave you with one question. I want to leave you with one thought. Because this engagement is going to continue. It's not going to stop. It's a dynamic thing. I'll frame this question as, if you are passionate about this space, what is that one big, hairy, audacious, not goal, but imaginative concept that you can think of? Because all those big, hairy, audacious, imaginative concepts collectively will make this space going forward. Thank you.
Now you also understand how much I enjoyed working with these two distinguished individuals in putting this together. Thank you so much, Shekhar, for those wonderful words, and really mean a lot. So thank you. Now, I think I have my fingers still crossed, and we are on time, actually. That is great. So that's a good sign that we are off to a good start. And it is now my distinct pleasure to get the keynote panel discussion going. And for that, I would like to invite a very special individual from ASME and the editor of Mechanical Engineering magazine, John Falcioni. Please, welcome, John Falcioni.
I think I'm good with this one. Okay, hello everyone. Thank you for joining us this morning to this very important keynote event held by the National Science Foundation. We're aiming to help define the opportunities and, as importantly, the challenges that exist in the area of research in materials and manufacturing for extreme affordability. Like the others before me, I want to welcome all of you who are here at Ball State University in person with us, and those of you who are with us virtually online throughout the world. I also want to thank the NSF for sponsoring this workshop and Ball State for hosting us. So thank you all. You've heard a lot of thank yous so far. As Mahesh Senegala graciously mentioned, my name is John Falcioni. I am the editor of Mechanical Engineering magazine, the flagship publication of ASME, which was founded in 1880 as the American Society of Mechanical Engineers. For those of you who are not familiar with ASME, it's a 130,000 member organization that strives to help the global engineering community develop solutions to world challenges by fostering collaboration among engineers and non-engineers, and by advancing knowledge through codes and standards programs, publications, conferences, meetings, and other initiatives throughout the world. ASME wants to help connect problem solvers, like many of you in the audience, with problems on the ground in places around the world where there's a need to improve the lives of people. A noble mission, you might say, but in the past couple of years, work to support this mission has begun taking great shape. And in one of our 2020 sessions, which are going to be held later on today and tomorrow, and they'll be also streamed live on the web, you'll hear more about a major initiative that ASME, IEEE, and Engineers Without Borders have developed called Engineering for Change, and their website is engineeringforchange.org. or as also is known as E4C. I think this initiative will truly excite you, so I hope that, that you will be tuning in for that. There are several reasons why we're here today. Some of them you've heard about from Mahesh and Shekhar and the others. And throughout the course of this two-day NSF workshop, we hope to get a lot accomplished, so there's going to be a lot of work ahead for us. But in the simplest of words, the reason we're here is about helping people to help themselves. The 21st century is characterized, or may be characterized, as an age of extreme. In 2007, for example, the 2 richest people in the world had more money than the combined GDP of the 45 poorest countries. Roughly a quarter of the population, about 1.5 billion people, lack access to electricity. 1/6 of the global population lacks access to clean and safe drinking water. You'll agree, ladies and gentlemen, that these are staggering facts. The good news is that with the help of people like the ones who will be sharing the stage with me in a few moments, and others sitting around me in the audience, and numerous others who are tuning in online, those who have the intellect, they have the drive, they have the passion, and they have the imagination to change the world. It's entirely possible, with the help of all these people, to also characterize the 21st century as the age of extreme innovation and great promise. I'm honored to be sharing the floor here today with 3 people whose work has been highly recognized and respected throughout the world, and most importantly, whose work is praised and appreciated by those whose lives and communities they have touched and improved. Our keynote speakers are Larry Barrow, Anil Gupta, and Amy Smith. So please help me welcome them up here to the floor. So a little bit about each of them, where a lot of it should be, because they each have tremendous backgrounds. Larry Barrow is a designer, a teacher, an inventor, an architect with experience in the design and construction of buildings and communities. He specializes in high-end custom houses as well as niche global habitats. He does so by leveraging his skills and experience in R&D, technology, and multidisciplinary integrated design, build, operate teams for sustainable architecture. His design and research focuses on material and method innovations for modular housing components and progressive building systems. He has co-authored the book, The Global Housing Crisis, an Industrial Design and Fabrication Opportunity in Architecture. He is also co-founder of Fab House, which I'm sure many of you are familiar with and which he will tell us more about in a few moments. Larry earned degrees in design and architecture from the University of Florida and Harvard University. Our second speaker has traveled far to be here with us today. He is Anil Gupta. Looking to the poor of India, business professor Gupta saw innovations and talent that were not being supported. So in response, he started the Honeybee Network and began searching the country with colleagues, often on foot, discovering numerous inventions that were developed out of necessity. He shares these discoveries with the global community, much as pollen gathered by the honeybee, in order to benefit both. And we're happy that Anil will share some of those stories with us today. Since 1988, the Honeybee Network's database of inventions and traditional knowledge has grown to more than 145,000. Anil Gupta also worked with the government of India to establish an innovation foundation that holds national competitions and encourages new innovations. These initiatives have uncovered devices such as a pedal-operated washing machine, a micro-windmill battery charger, a hoe powered by a bicycle, and many, many other inventions. And our third speaker is Amy Smith. Amy is a senior lecturer in mechanical engineering at MIT. She has served in the U.S. Peace Corps in Botswana and has done field work in places like Uganda, Senegal, South Africa, Nepal, and Haiti, among many others. She is recipient of many awards, including the B.F. Goodrich Collegiate Inventors Award and the Lemelson MIT Student Prize for Invention for her work in creating technologies to improve the lives of people in poverty. In 2002, she began teaching D-Lab, a series of courses and field trips focusing on the development and design of appropriate technologies for international development. She also founded the International Development Initiative at MIT, the Innovations in the International Health Program, and the International Development Design Summit. She was selected as a 2004 MacArthur Fellow and was recently named one of Time Magazine's 100 most influential people for the work she is doing to promote local innovation and technology creation. So those are the speakers this morning, and it's quite a great group that we have. The program will begin with our impressive list of folks giving us their perspectives and an idea of what impassions their lives. This will be followed by a group discussion period and also questions and answers from all of you. So we encourage your questions. If you're here with us live, please write your questions on the cards that have been provided on your chairs. And when you have your questions filled out, pass them to one of the volunteers who will be picking them up. If you are online and listening to us live on the web, simply tweet your questions by adding the hashtag RIMMEA. That's hashtag RIMMEA. Because it's not me whom you've come to hear, please join me now in welcoming our first speaker, Larry Barrow.
Thank you very much. It's my pleasure to be here. Let's see if we're on here. Yeah. Thanks to all who put this together, especially the Ball State persons on the ground here who've exchanged many emails. Thank you guys very much for having us. A note from our friendly attorney. Let's look at it right in the face. This is a student, Olatoso Kuso, that studied with us at Mississippi State. And he's from Nigeria. His father's an architect and his mother's a medical doctor in Nigeria. And these are the kind of students who've come around the world to study with us, who've helped us keep our feet on the ground here in the U.S. about the real problems and issues. As we've all talked about the catastrophic events that are occurring around the world between tsunamis, hurricanes, tornadoes, and other catastrophic events in terms of earthquakes, we know the scale of the problems before us. It's an overwhelming problem. I stand before you humbly with some ideas today that are a starting point because this is so complex. None of us have all the answers, and most of us don't even have probably the right answers yet. But, as Emerson said, let's look for the sunshine in the midst of the shadows. We can do this together. I have spent most of my career as an architect trying to collaborate. I was an architect traditionally till about 1985, and because I didn't like having an adversarial relationship with general contractors, I decided if I couldn't beat them, I would join them, so I got my contractor's license. My wife thought I was ruining my career. So far, so good. Maybe not. And so I've been collaborating professionally for most of my practice, actually. And I've always pursued that. So we have to work together. We know this. We have to research together. It's already been mentioned. The unique thing about this event, I thought, like you guys, I've never spoken to a group of engineers. So I think one of the key things we can focus on is that we're all very different in our backgrounds, but the need to work together is great. The thing that holds us together is values. Certainly there's the need for economic development and financial gain based on ideas and inventions that are necessary because that's the only way to sustain, and I completely agree, the need for such large housing quantities. But the thing that holds us together is some type of value about trying to help persons in need and those who cannot really help themselves often. So amongst us, of course, are white people. I'm an idea guy. I'm a dreamer. I admit it. But we have what and how here, too, and that's what's very important. So others have said this. Many are here with us today. Walter Gropius knew this in the 1930s. He established Bauhaus, and you can certainly see the reference to Fab House and Bauhaus. And he was very much about mass housing, social issues. The modern architects in the 1930s and 40s were absolutely committed to this. They made many attempts, many of which did not work, but they tried. And we learned from our predecessors. So they have written and thought about where we are today. Gropius was a huge fan and wrote much about the integrated idea of building. He understood the great works of Europe to have been accomplished not by designers who did a building set of plans and gave it to a contractor. It was developed by master builders who had come up through the guild system to make buildings. And he very much promoted this idea of infusion of engineers and contractors and architects working together. And he called it a fusion of art, science, and business, which is what we are trying to do and what I think this conference is all about. So Gropius understood this, and he wrote much about it. Architecture is the art and science of designing and erecting buildings. Sounds fairly simple, even though we all know it's very hard, especially done well. It's really hard to do it for affordable housing for persons who have little money. That's the real challenge. So, Shama Al-Arayed, thank you very much, Shama, for being here, and I co-authored a book looking at these attempts by 20th century architects, which there are many examples. And we compiled an analysis of each of these examples, looking at what worked and didn't work. And this is what we looked at, was the problem, attempts, and looking at issues, what the barriers were to these attempts. One of the things that we know to be true, and of course architects are incredibly aesthetically driven. You know, we have pretty pictures in magazines. We're not necessarily focused on really simple, and it's quite an elitist position, quite honestly, exclusive position. So what we find often is the process of architecture has often focused on objects and products, not places and processes. And I think that the idea of process design is very, very critical to this issue. So we have not looked at things holistically. And again, it's hard to integrate. But this is one of the key things I think the theme of the conference is about, is cross-disciplinary work and holistic thinking in terms of design process. The other thing we found, of course, is that classically architects are not real good with dealing with budget. Even in, let's say, well-funded projects, much less affordable housing. So, you know, we're strike three, we're out. But at any rate, we know that we have to deal with money and budget up front as part of the design process. We haven't dealt with management well. We're not really particularly known to be good managers. And we have not engaged in a really meaningful way the manufacturing principles and industry. So thank you guys for being here. So these were the things that were some of the key points in the book. In our research over the last 15 years, you know, we found certainly that other people understand more about technology than architects. Technology in the manufacturing world for decades now has been understood to be, of course, hardware, software, and also humanware. Humanware in terms of people, and more importantly, the reasons for using hardware and software. In other words, values and who we are. And this is very important. But this is, some of the experts certainly understand this. Also, in the idea in the manufacturing world, to address complex manufacturing design problems, it's absolutely understand that it takes people of different types, i.e. dreamers and imaginers and creative artist people, problem solvers, and implementors. So this is something that it takes a diverse group of people to really design and collaborate to work together. Pathfinders, dreamers, artists, the ephemeral world of these soft, non-edgy things, which is what architects really do at their best in terms of alternative thinking, where you have to engage engineers and rationalists and performative kinds of issues, as well as implementation. Builders, machines, and nice, you guys have the digital fabrication lab here. All these issues of how you can make things from ideas. So ideas and concepts. 2005, following Katrina, one of the things we developed in the lab, and I think I published this at Acadia, you guys have seen, the idea of a performative kind of shaped egg modular house that was aerodynamic for wind loads, as well as a flotation type system. So, the idea that something could float. So we worked on that for a while. We haven't commercialized it, but it may be very relevant based on the more pending hurricanes and tsunamis. In 2007, we were invited to Pakistan with the pursuit of developing affordable earthquake-resistant housing in the Himalayan mountains after the 2005 earthquake that killed 200,000 people. We have not been able to implement that project yet based on instability there, but we have researched there and been there. And we became very interested at that point in global housing, and particularly earthquake-resistant housing. That generated the idea of multi-story units, partly because we realized single-family housing was not really the problem. The global housing issue is so huge. It's typically in urban centers and cities where people have moved from rural settlements into cities, and we knew we had to look for higher density. So we started looking at multi-story units, trying to use modular kinds of systems, and the idea of prefabbing modular units that could be put in place as a unit. So these were some of the earlier sketches. Out of this was developing likewise from the earthquake resistance idea. So the red nodes are actually flex joints. So if you can imagine that if you have a hinged rigid frame, your body is made up of rigid frames and flex joints, the cartilage. The basic concept is to develop a structural frame system that has rigid frames that has flex joints to absorb lateral shock. So this is the basic concept. So this is something we developed with the idea of looking at flexible type systems here that can absorb shock waves. So the entire structural system literally is a cartilage type system, as well as other sustainable systems. We were invited to Nairobi this past fall to the ISOCARP International Congress. That's the International Society of City and Regional Planners. And there we visited one of the largest slums in the world, Kibera. Some of you may have been there. And these are some of the techniques. Typically the housing is 10 roof sheds and 10 walls. In this case, I was very interested in the local earthwork. It's literally taking the ground and using mud and daub type system for housing. So we made friends there. So we came back, we did more ideas and sketches, developing the ideas more. So I'm going to run through real quickly through sketches. These are what people do on airplanes when they're bored and they can't get emails, and my most productive time is always on airplanes. I figure when 600 miles an hour isolated with a pen in my hand is great. So at any rate, these were sketches that we have worked on. As our work evolved, we were looking at an idea of a stacking system, but we began to develop an idea of a frame system with a node system. This is the idea of the flex joint and other things. Some of the things that we're looking at in terms of entryways is a Bedouin tent type fabric system. Nairobi specifically is a very subtropical, tropical environment. So looking at the idea of using maybe lightweight tent structures for entryways and things. This is an idea of a man-made and natural system, essentially a bamboo structural frame member, cross-section through that. The idea is to use man-made and natural fabrics where you end up with a bamboo type outer core with an interstitial type composite injected panel. So you end up with a kind of an organic system with bamboo elastic thing with a mass producible type shock absorber, if you will. So we'll see sketches here, cross-section, some of the ideas for paneling techniques. So let's try to prove this, which we're working on trying to launch a project in Kenya at this moment. This is a schematic sketch of the Kibera. The next slide I'm going to go ahead and tell you, I'll apologize in advance because you're going to see me erase about 500 houses, and I know that. So it's part of the complexity is how do you actually go in and do an intervention? And my arrow's not coming up there in the map. But at any rate, there should be a red arrow there about intervention. But we actually schematically have drawn this to engage the conversation in Nairobi right now about what do they really want to do in terms of trying to intervene in that system. And we're going to research that. So if you look at that, essentially right now you have these one-story tin sheds. And what we're proposing to start the conversation is we go in and we use about 5-story structures. We go up about 5 stories because we can do that without elevators and simply use stairs to get up. And create open spaces for wastewater treatment, water harvesting, urban agriculture. It's amazing how much farming they're doing there with what small amount of land they have. And create green spaces that also provide, of course, vegetation and recreation for the kids. But most importantly, production space in terms of urban agriculture and domestic wastewater treatment. All of that will take a lot more research. But looking at some ideas, I'm going to move quickly. The idea of the shape is not only is that structurally efficient, we think, we'd like to simulate and confirm, the shape is, but it's also spatially efficient. The idea is that you end up with the highest point where you can navigate in the hut or the home. You sit and you lay, so it's essentially very efficient use of space. So you can stand, sit, or lay down. So looking at some sketches here that we developed, this is the basic idea of using local materials. Now for my digital fabrication friends in Acadia, I'm going to run quickly through some Rhino models, but this is basically the idea of the structural frame, the standard module, and then the idea of being able to mass produce a very repeated kind of system. And these are, we foresee these being eco-cells, essentially water harvesting cisterns with other bathing and sanitation type things that could be produced in mass. So the idea is a plug-and-play system. You have a structural space frame, mass produced, all universal, field assembled that you can also then plug and play. They have separate skin structural systems. Roof view. Okay. So essentially what we're looking at is trying to develop a machine template. In other words, a man-made prefabricated type template becomes a pattern that can then be used with local handcrafts and materials. So we have a combination of man-made and handcraft type ideas. 2005 Performance House. We had an all-U.S. market. Performance House with the Gulf Coast. Everything's done here in the States. Get it done. Then we went to Pakistan. We started thinking about shipping to these areas for remote earthquake-resistant housing. So we said, well, we'll make here, but we'll sell in the global market, not in the U.S. market. Then we went to Africa and other places. They said, yeah, but we want the local materials. And, of course, we know it's this thing we should use local material and local labor. So they said, we want the economic development here. So now in Kenya, they're telling us we want it here. Okay, it's good. It's good economy of local materials, local skill, local craft. So we move that over there. Where we are right now is we're like doing this. Like we would like to do the R&D here and test and maintain IP in the States, but we're teetering. So we'll see where that goes. We prefer not to do that, but that's a possibility as well if we don't get U.S. funding. And there are persons that we're talking to. That might happen. I guess, worst case, I moved to Africa too, but I don't want to do that. But anyway, but we can. We might. We'll talk more about that. So here's my friend. I'd say we made friends. Here's my friend. It's a great slide because the reality is that when we draw these fabricated models and things, we're dealing with people. When I erase 500 houses, I just erase these people's community right here. How do you intervene? How do you even begin to, if you're working in situ, how do you even begin to work in that context? It takes a lot of community planning and ideas. So we also know, you'll notice I modeled a linear system, a good modern architect, simple way to do the building. The reality is it's probably not the way to do community design. We know this is what's modeled in the Rhino right now. We know that shape matters. These nodules can be done in different ways to create different places, spaces. Again, we can't just do a block. We have to create the spaces and the places. And this is a failure of modern architecture to deal with this. We'll see the idea of Christopher Alexander's ideas of patterning. Can we not see this in terms of the idea of repetition? So there's a lot of work to be done. This can be codified. I feel like in 20 years, 40 years, we will be able to scientifically understand space and place and what these factors are to create quality spaces affordably. And this can be codified based on this kind of language. So industrial design. Chime and I wrote the book, Industrial Design Opportunities in Architecture. So for like we published the book, we titled it, and I keep thinking to myself, is it that easy? Well, no, it's not. There is a difference. There is a difference. Cars, trains, and planes. Transitional, temporal. What is the difference? A home is a destination point. You know, architects need to diagram. I made this diagram this morning about 5 o'clock. I finally got it. It's so simple. One's an arrow, the other's a dot. It's a no-brainer once you get it this simple. It's a destination point. It's constant. None of you are going to return to your plane. Some of you might if you're rich. You're going to return home. There's something very different here. Place design. There's something very different about architecture versus industrial design because it's a very different animal. Therefore, architects should feel very much a part of industrial design techniques for housing because it's critical for the success of it. So the other issue, electronic engineers are here. My background's in IT, and so I very much am excited about virtual communities. So how do we even define home anymore? Home is not physical. It's also virtual, i.e. Facebook, what's happening in the world right now. So even the way we think about home and community has to be rethought based on community design because it's not only physical, it's virtual. And boy, is that a lot of potential. I have to give credit here to Bill Mitchell at MIT, humbly. He passed away this year. And my chairman at Harvard, Spiro Polalis, for educating me about these things. So, all that said, what do we do? John asked a question of me last night. I sent an email yesterday morning to the University of Nairobi in Kenya about this complex process regarding negotiation there with the Minister of Housing about this complex issue. This is a really complex problem. To do it right takes research and effort. So what we are proposing is the idea of a universal framework to deal with international issues in global housing, to look at climatic, cultural, local materials, crafts, and virtual issues. This is not an M&M's cookie. This is my idea this morning at 5:30, whereby this is the globe with the equator. Wouldn't it make sense climatically to have universities that are in certain tropical or subtropical or polar regions of the world work on climatic design in terms of global housing together? So the idea is to have a consortium of affiliated universities that would work on global housing issues and share knowledge. So some of us may be homeless even though we have physical homes if we don't have a connection to a place. So I think that's the other thing to think about is even the Kibera, I was amazed there at the social network, and that's those people's homes currently. And some of them probably have better homes than we do, even though physically we would think that they're inferior. So I think we have to be very sensitive about what home really is. So with that said, I hope you all have safe travels home, and thank you very much. If you want to see more about the work, you can see my architectural website here, or our VAP House website at vaphouse.com. John Lennon said it best, so thank you guys very much.
All right, thank you, Harry. Thank you. So before we get Anil up on stage, let me ask you a question. In fact, do you guys want to set up Anil's computer? You might want to do that while we ask the question. But before the question, I want to throw some numbers at you, okay? And these are probably numbers that I know you're very familiar with. The world's population is approaching 7 billion.
Right.
The United Nations Population Fund projects that 3.3 billion people living in urban areas alone in 2008 will grow to 5 billion by 2030. And 81% of this growth, they say, will occur in developing countries. So where 1 billion slum dwellers live today, the number is to double to 2 billion by 2030. Obviously, the need for housing is and will be exceptional. I'm preaching to the expert. So tell me, what is the extent of a single solution like Fab House? How much can you do to address this tremendous problem? And if it's not about one solution, then how do you leverage the work of others?
Okay, I think one of the things that's become clear to us in the last year or two is that in the white paper that we wrote for the conference, we don't have one product idea. What we feel is most critical is a process whereby we can have a framework to work with places, countries, communities in the world, whereby local persons in terms of either craft or business partners can work with us to implement appropriate kinds of products in their community. Often that we absolutely feel, and appropriately so, that will involve local materials in craft. So it'll be a combination, and those things will vary around the world. Obviously, another huge factor for sustainability, of course, is just simply the green design. If you have a tropical kind of place versus a cold weather place, these things are all going to vary. Interesting enough, most of our opportunities right now are coming from subtropical places, and part of that simply, I think, historically, people like living in nice weather. So it does offer some simplistic ways to deal with ventilation and other things versus mechanical kind of systems. But we think that the process, and that's part of the reason we're talking with the idea of developing the university research centers. A lot of these things we think are universal principles that can be globally identified, and yet locally they have to have specific implementation strategies to make them work culturally and sustainably. So that, I think the contribution of us may not be so much of what we actually do with the actual business. I think the research from an academic perspective is probably the greater value to allow principles to be understood and implemented.
Interdisciplinary principles. Very good. Thank you. Thank you. Anil?
Good morning, friends. I'm a worker bee of the honeybee network, and I decided that I will leave the queen bee here so that you can make a honeycomb. And ASME and NSF workshop, it provides an excellent opportunity to us to engage with a worldwide community of engineers who also are represented on the Engineers for Change platform, with whom we want to engage. We want to engage because we have a huge database of grassroots innovators, and each one of them needs mentoring. They're using materials which are 50-year-old or sometimes 100-year-old. So they would also need access to new materials. And they need access to creative minds which are willing to learn and share. So it is with this mission that come here. And I must also remind you that while the term base of the pyramid is used very often, it often implies that people at the base of the pyramid are economically so poor that they can't possibly think for themselves, and therefore we need to do something for them. Now, I'm very happy that in the beginning, in the inauguration of this workshop, it was made very clear that the approach of this platform is not to be philanthropic towards them, but to engage with them. And how do you engage with them? By recognizing that the same people could be at the top of the ethical pyramid, they could be at the top of the innovation pyramid, they could be at the top of knowledge pyramid. Language shapes habit of thought. If you use bottom of the pyramid as a term to signify a certain class of people, you assume that they are at the bottom of all pyramids. And I would request that we should not do this mistake. Honeybee Network does not believe that the creative people of our country, and for that matter around the world, are at the bottom of all pyramids. Now, what does Honeybee Network do? It brings nameless, faceless people in contact with the network, and they get an identity. That is the minimum contribution that we do in every almost case. And we realize that this identity is a very powerful identity. It makes us vulnerable so that we can empower ourselves and, of course, empower them. So what is the key principle? The key principle is that because they lack material resources, what else can they leverage? They can leverage knowledge resources. They can leverage their institutions. They can leverage their values. And how do they do that? So let me take up a few examples of how they do that. And I must also say that my generation and many of us sitting here are guilty of having lived with lots of problems unsolved for a very long period of time. Our country, in our society, we are now deciding we will not live with problems unsolved anymore. And this is the message that I would like to propagate to our people, our young generation. And how do we do that? Look at this hand pump. This hand pump in dry regions all over the world leads to a situation where water spills over when you drink water from this hand pump, because the output is more than what your hand can hold. Now, this is something which is known to all of us, but we did not do a solution. We did not bring out a solution. This is the solution that several innovators put together, brought out. And what was the solution? A small pipe for drinking water and a bigger one for filling the bucket. Costs only 150 rupees, about $5 extra. And in that case, even then, if there is some spillover, animals can drink water from this trough. So the inclusiveness of innovation need not be only for human beings, but also for non-human sentient beings. When we design things, we also need to design, for example, in houses, a platform for feeding the birds, which in our country, in our society, is a very important part of our life. The first bread that we cook in our home is not supposed to be eaten by us. It is supposed to be eaten by the animals, by the birds. And every day I feed the birds before breakfast and before lunch. Now this is also a part of culture that we bring in and that we need to learn from people. This is another defective design, despite UNICEF and all the world bodies which have been implementing these hand pump projects around the world. When you put the handle down, it strikes at the base of that socket, and socket gets cut. So what do? They put a small sling of wood to prevent it from further damage. Otherwise, the plunger will come out and the hand pump will not work. Now, we have lived with this problem, and we only could reduce the damage by putting the sling. Where is the solution we found? We found this solution in Bastar, an interior part of India which is insurgency prone, where there is a lot of violence taking place because people are extremely unhappy for the indifference of the state and the market. It is there that we found this difference during our Shodhyatra walks in that region. And this is not the only one. Another solution, very interesting solution. It serves the purpose. It doesn't damage the hand pump. It uses something available locally, and it's perfect. It's better than the first one because it doesn't create the impact that you will have. When you have a wooden support, there will be an impact, reaction, and there will be hand has to absorb that reaction. In this case, it's very smooth. This is another very interesting example that we saw, a two-story energy harnessing system. All of us in our kitchens have a gas. When you put the vessel on the gas, the flue gases go around in the atmosphere. They warm up the atmosphere. That heat is not being used. It is making the ambient environment hotter. This lady didn't have that luxury. So what did she do? She made a shelf on the top of the stove. What does the shelf do? On this, she keeps the panicles of the paddy. Now look at the science that she is using. The rate of expansion of the husk and the grain are different. Therefore, when she thrashes the paddy panicles, it takes less energy, less effort to take the grain out of the paddy panicles. Very creative, very creative. That heat is a resource which she will not lose, but we all in our kitchens lose that. We could also use a shelf on the gas and use it for drying the vegetables which are left over in our kitchen. We don't do that. Look at one more modification. Now here is a 4-story system of energy harnessing from Meghalaya, northeast of our country. The first shelf is for drying the wood which is used for a trolley on slopes, mountain slopes. It seems, and many of you may know better than I do, that when you heat the wood it becomes stronger. Then there is a second shelf for firewood. In the place which receives the maximum rainfall in the world, you better keep your fuel wood dry. So that is firewood. Third, for vegetable, for meat, to dry it up. And fourth is for the seeds which are then saved from the insects because of the fumigation. 4-story system of energy harnessing. What are we going to teach them? We need to learn from them that these are the constructs for architects, even more interesting, new designs, new ways of using energy that we have wasted for such a long time in all of our houses. This is an interesting wall. And since I realized that Mahesh and all of you are architects, you would enjoy that. This is a wall which has no black patch. So when we were walking in Anantnag in Jammu and Kashmir, we were intrigued. We thought it's a new house. So we went inside and talked to the weaver, owner of this house, and said, and obviously it was obvious to us that the house was very old. So we said, how come that there is no black patch on this wall? He said, he didn't realize that. I said, yes, what did you do? How to build the wall? He said, we mix gunny bag, the jute fiber, with the clay, we pound it, and lo and behold, it becomes antibiotic. Because the organic matter which is grown by the winds, which then is attacked by the fungus, which then bursts and creates black patches, do not do that on this wall. Now the analog of that, modern analog, is titanium dioxide, nanoparticles mixed with the paint will make a surface antibiotic. Very costly, not affordable, not accessible for these people. They have developed their own material science research. Now we do not know whether the proportion that they have can be modified, can be made better, can last longer. This is where the challenge is. This is where I would like material scientists to engage with us and work out an equation by which then people can plug in their local materials and work out a functional design for their own conditions, for their own local resources. But surely it is something there to be seen and to be inspired. One of the lessons that we have learned in our work is that scale should not become enemy of sustainability. Very often people ask me, how much diffusion has taken place for these innovations? In many cases, not much, actually speaking. And I'm not worried too much about it, because if they solve local problems in local context, it's all right. They have legitimacy. not all solutions must diffuse to millions, because otherwise problems which are localized over space and over social segments will never get attention. They will lose legitimacy for being solved just because they affect small community. And I think the ethics of that exclusion must be kept in mind, that we cannot exclude somebody just because their problem is not the universal problem. So we need not, in our search for universal solution, ignore local place-specific problems. The trade-off between affordability and accuracy may make a significant difference to accessibility and effectiveness. Higher accuracy does not always lead to increased effectiveness. You could design a hand pump, as we saw earlier, which may be very exact in terms of its ability to not damage the wall, but not damage the structure, but that may not be affordable by many people. So I would not mind making a small trade-off between affordability and accuracy, so long as affordability is maximized, accuracy is slightly minimized, so that we can live with little less efficiency, but at the same time little more accessibility. This is a beautiful concept, and in Sanskrit we call it samvedana, or Hindi we call it samvedana se srijanshilta. Samvedana is a beautiful word. Sam means equal, vedana means pain. When somebody else's pain is felt by me exactly as that person feels, it no more remains that person's pain, it becomes my pain. And the creativity which is born out of that realization of pain of someone else is a very empathetic, it leads to empathetic innovations. So empathetic innovations follow from internalization of the pain of others. And I would plead that when we join hands and we try to work out solutions, we also reflect on ourselves as to how much it becomes meaningful to us if we can do that. And how do we do that? Just see, this is a very simple example. This is a clay pan. We use non-stick pans. The non-stick pans cost about $5, $7, maybe $20, I don't know how much a year. And after a while you see the metallic surface, and that Teflon has gone into your stomach, causing all kinds of cancers and whatever have you. Here it is porous material, clay pan. The liquid goes into the pores. It cannot be scraped off. It is cheap. The food is more tasteful when cooked on the clay pan. It is affordable, $1. And this to me is the symbol of what affordability, extreme affordability would mean, that we give higher value at low cost. So we are making the food more tasteful and not less. This is another example of how when the burden becomes responsibility and a concern triggers the creativity, we encounter the Gandhian spirit. This fellow is using pressure cooker for making coffee, cappuccino coffee, anywhere, no power, need for power. You need a steam, and that's what it does. This is a very interesting example. Many poor people can't afford to buy grains in quintals or hundreds of kgs. They buy half a kg, they buy 1 kg. Sometimes they buy for every day. The most vulnerable person is whose inventory is only 1 day old, just for 1 day. How do they grind that grain? They can't afford to go to the flour mill. So they can use this scooter-mounted grinding mill, or they can have a washing machine on a scooter, two-wheeler scooter, and that is making services available at your doorstep. So what do? We are talking about creating new constraints which we have to create conceptually in our mind, in our institutions, to generate new generation solutions. So look at this. The windmill on the left costs 5,000 rupees, which is about how much? $50? $100? $100. $100 bamboo windmill. We took it from northeast Assam to Gujarat, where we wanted to pump brine water. It costed us 50,000 rupees, about $1,000 diesel engine in one season for making salt. Now this is a modified windmill which costs about $1,000. Sorry, yes, $1,000. And this windmill costing $1,000 produces about 1 kilowatt of energy and pumps brine water. It is affordable, it is easy to repair, and it can bend at 90 degrees when there is a big storm. No windmill can bend down at 90 degrees when there is a storm. It can. So it has multifunctionality, it is flexible, resilient, affordable, and serves the purpose. This is a biomass gasifier, $500 per kilowatt hour energy, uses very interesting concepts. I'm sure it can be further optimized. I'm sure it can become more cheaper. Maybe the cylinders can be optimized in their design, the filtering system for taking the sulfur dioxide out can be done better. A lot of things can be done here. This is another example of a pollution control device triggered by Samvedana. What this device does, it captures about 1 kilogram of carbon per month from a 12 horsepower engine and reduces noise by about 40%. He doesn't know engineering. He's not educated. Most of these people are dropouts. But they have intuitive understanding of how things work. And this fellow has designed this. Surely it can become better. It can become tidier. It can become smaller. It can become more compact. And this is where the engineering community has to engage with these people. So what am I saying? I'm saying that frugal thinking can lead to new heuristics for flexibility, multifunctionality, and of course affordability. And these heuristics have emerged from the journey that Honeybee Network has taken together with GYAN, National Innovation Foundation, for such a long time. And we are trying to link this triangle, innovation, investment, enterprise, because we realize that not all innovators can become good entrepreneurs. So we also need to realize that to make these innovations accessible to people, we'll need to create supply chains. We'll need to create new mechanisms where the transaction cost of innovators, of investors, of entrepreneurs are reduced. This is another platform we created for this purpose, to engage young minds, techpedia.in. And techpedia.in has, let me just show you the site. This site has 104,000 engineering projects done by 350,000 students from 500 colleges. I'm sure you know that in US you cannot find the projects of, let's say, Ball University, Purdue University, MIT or Stanford at one place. In India we can. And what is the purpose? Why? What do we want to do it? One, we do not want any engineering student to do something that has been done before. So we want to raise the originality and innovative quotient of our country. Every young person must do something new, something different, something better. And we want to link this community of students with the unsolved problems of our society, of micro and small enterprises, of informal sector. We want that when they do a project in the final year, it must solve some real problem. And I believe that anytime we solve a real problem, we become better human beings. So these engineers will become also better, not only better engineers, but better human beings. And that is the reason why we have created this platform. There is a window here, problem in search of solutions from industry, from grassroots problem, innovations waiting to be augmented. And you can search any problem. Let's say if you write gears, and you will find here 60 different projects on different kinds of gears that people have done in different places, in different institutions. And these problems may be IIT Bombay, some local engineering college, some Rourkela, and this creates a knowledge network. So we would have a new platform for distributed knowledge management, so that one problem which is complex can be converted into modular design parts and outsourced to a large number of students. They will work together and solve this problem. And I would wish that there should be very active exchange, active collaboration between your platform and this platform that we are creating. Going further to see how we want to do that, we want to overcome inertia. We want that while our generation is guilty of having lived with problem unsolved, the new generation, the new leadership, the young generation should not be given this luxury of living with problems unsolved indefinitely. We also need to take these solutions around the world. I call it G2G, grassroots to global. And that means that the prevalent model of globalization where large corporations sell things to small people and take money out of their pocket, we want to buy their things and create large markets for those things so that people will get money from our pocket when we buy things from their pocket, made by them. And let me also say that there are some very interesting insights here. This innovation of stand on the front wheel of the cycle instead of the back wheel, we found in a slum of Rio de Janeiro, which means that India and China, which have the maximum number of cycles, could not invent a stand on the front wheel instead of back wheel and make a bench here. So sometimes innovations may emerge not where the density is high of an activity, but where the density is low on the margin, so to say. And that's why it is an interesting insight way to look for solutions. So we have large number of solutions in cycle-based devices. Cycle is the most accessible means of transport for poor people, and yet so little work is going on in making cycle as a multifunctional tool, as a grinder, as a water pump, as a workshop, as a sprayer, whole range of things that can be done by cycle. So I would wish that we have a whole consortium around cycle and build whole range of applications around cycle, which is making it better. We had a workshop in Limpopo. We took our innovators. A donkey cart using the old axle of the automobile had this differential weighing about 30-40 kg, which means that if you remove it, you need one donkey less. Very simple. Nothing very great about it. Our innovators could think. Why couldn't an artisan there think? Because in South Africa, unfortunately, there are no roadside workshops. Having a workshop on the roadside is prohibited by the law. You cannot do vending on the roadside. It's still an apartheid time law which continues to operate in that country. So there's no skill ladder being built. People who can move from roadside to small shack, to small shop, to small farm, to small enterprise, which we have in India and many other countries. In China, we have a very strong network, China Innovation Network, which we have triggered in the last 6 years. They have now pooled about 6,000 grassroots innovations. And here there was a need for a breathing apparatus. The parents of this child, this lady, this girl couldn't afford to keep her in the hospital. So they designed a contraption using cycle and some other parts, a breathing apparatus. In other words, what I'm talking about is happening in India is not happening only in India. All over the world, such innovations are emerging at grassroots. We need to learn from them. We need to leverage them. We need to give them new materials, new toolboxes, new ways of creating structures so that they can become more efficient. So we have sold products all over all the six inhabited continents, including in US. And there are queries coming from all over the world, from USA, South Africa, Turkey, Peru, Singapore. So there is a worldwide need that is evident from these queries, need for affordable solutions. There is no question about it. I would also like to share this thought with you, that how do we create autopoiesis designs that can self-correct themselves during the implementation process. In other words, a work in progress. We don't give the ready-made cloth to a user. We give them semi-stitched or cut cloth. They will tailor it to their needs and fit it to their body. In other words, design which get completed in the hands of users. A work in progress, so to say, a partnership between users and the designers. And to me, it seems that autopoiesis is something which is inherent in nature, but which has not yet become part of our pedagogy. So let me conclude by saying that Honeybee Network, which was started more than 24, 25 years ago, has been supported by Srishti, which is a voluntary organization. Srishti is an incubator of institutions. It created GYAN in '97, a grassroots innovation augmentation network, which is an incubator, and created National Innovation Foundation in 2000 to really provide a national register of grassroots innovations and provide them support. This year we have launched a new concept called as Technology Acquisition Fund, where we will acquire the rights to some of the technologies which may not see the fruition in the near future, but which by pooling together can create new products. So combining the disparate solutions distributed around and generating new innovations that can solve. And I'm sure that if you all join this effort, we can create very powerful energy out of this synergy between our effort and your work. Thank you so much.
We're making a quick computer shift again. So, Anil, you've made a lot of very provocative, very interesting comments. And I'm not sure where to start, but I guess we should talk a little bit more about the sort of the notion of frugal thinking. You talked throughout your presentation about that, and I know that you've written about that you've written that nature is frugal also, and sort of the whole concept of the human spirit. Can you shed a little bit more light? And then I know that you'll be probably talking a little bit more on this throughout the next couple of days. But
yeah, I would say that, as I mentioned, that when people lack material resources, when people lack a lot of money, a lot of concrete, a lot of structures, a lot of iron, a lot of wood, a lot of tools, they have no choice but to be frugal. That is a compulsion for them. And that compulsion, if we could create for ourselves, then we can also be frugal. And frugality is very at the heart of empathy, because it generates a common community of thought, community of practice, community of behavior. And therefore, in nature there is no concept of wastage. There is no wastage in nature. If there is no wastage in nature, why can't we incorporate that lesson in our working? When it comes to using frugal thinking to generate frugal design, I would also think that we should look at the fact that not all materials fatigue at the same rate. For example, the steering wheel of the car has maybe life of 100 years. The car itself may have life of 15 years. The gearbox has life of about 30, 40 years. So our innovators will take the gearbox from the old engine, from the old car, steering wheel from somewhere else, and combine them and develop new designs, because that's very flexible, that's very useful. So maybe in future we will not only have libraries of books, but we'll also have libraries of components around the world. And those components will have life because materials don't fatigue. So this whole junking philosophy that we have created in the West must be junked. And we should think about how materials which are going to last longer become available to people to incorporate them in the future designs more and more. So I think there is a lesson here from the innovations that our common people design around the world, that we should think of frugal thinking leading to more efficient and more effective and more long-lasting solution, which is what sustainability requires.
Right. I think, at least in my mind, you're raising as many questions as you're answering. So, ladies and gentlemen, Amy Smith.
Great. Thank you. Good morning, everyone. So I work at a program at MIT which we call D-Lab. And to start, I'll tell you a little bit about the program before going into some specific projects. So D-Lab began about 10 years ago with a small program focusing on some needs in Haiti, working with Peace Corps volunteers there. We had about 20 students, and over the last 10 years, it's grown quite a bit. We're now offering 12 classes with close to 300 students, and we're working in 20 countries around the world. We offer classes that fall into 3 categories, which define some of the important Ds, which are development, design, and dissemination. And because it's MIT, we do a lot of focus on the technology design, but we offer a broad range because we understand that all of these things are important if you want to have an impact. When people ask me sort of what are some of the key things about D-Lab, so I think first and foremost is that we work on real projects for real people. And that's because we don't want students to think they're designing for the developing world and yet not have any user impact and not actually know whether or not what they're designing is something that people need. So that's one of the key things. We focus on solutions for people living in poverty, and we believe that technology does have a role to play in improving those people's lives. We stress hands-on learning and experiential learning both in the classroom and in the field. So when we do work with communities, we're very much engaging them in hands-on activities as well. And we'll believe very much that a single discipline cannot solve any of these problems. I think we've all referred to the need for multidisciplinary solutions. And one of the key things that we try to do is to foster innovation and building capacity both of our students at MIT but also in the communities where we work. And we try to make a long-term sustainable impact in those communities. So that's sort of what D-Lab is about. And last night as I was reading through my packet, I was enjoying reading what Mahesh had written in his opening sort of introduction to it all, and at which point I read the sentence that said, this is precisely the paradigm which this workshop is designed to shift away from. So I thought, oh, well, that means something in terms of my talk, doesn't it? And so what I wanted to do was to take some learnings from the type of work that we do, which is more of a community-based approach, and try to think about how can those map onto what we're here to do, which is to look at sort of a shift away from these grassroots efforts to sort of what you refer to as the BHAGs, the big audacious goals of how can research impact these things on a very broad scale. So that's what I'm going to try to do, and we'll see what happens. So there are 3 projects that I did want to talk about in the 3 Ds, design, dissemination, and development. Okay. So looking first at the design project, this will be in the context of a program that we've been working on. It's one of the first D-Lab projects. It's called Fuel from the Fields. And the idea is that you can take agricultural waste material such as this sugarcane waste, which is shown here, and using very simple equipment, you can carbonize it. This is a 55-gallon oil drum that can be used to do that. And then you can take that carbonized material and you can form it into briquettes and use that as a cooking fuel. And it has three great advantages. One, environmental impact. You don't have to cut down trees in order to make this charcoal. Second, economic impact. It's a very high value product in a place like Haiti, so it allows farmers to take a waste stream and turn it into a profitable item. And the third impact is health, because this is a cleaner burning fuel than either the original residue or the wood-based charcoal. So it has some great opportunities. And when we first started working on this, we made those briquettes by hand. They looked sort of like very overdone hamburgers. And when we tested this, what we found was that these briquettes, they burned quite well, but they were, their energy density wasn't so high because they were quite light, and also they weren't that strong. They broke as the pot was resting on them, and so a number of the briquettes would actually fall through the grating and burn on the ground rather than under the pot, and so people were losing energy that way. So what we knew we needed to do was to make stronger, more dense briquettes. So we looked at what was out there, and there was this wonderful machine in China which cost about $8,000, which we knew would not be accessible to Haitian farmers. So we started thinking about how could we make something that was smaller and cheaper. And this was our first prototype, and it cost about $25 to make. And I have to admit, I took the easy way out, and I didn't bring all of the prototypes here. I have 3 of them, but they're heavy. So in any case, this is the first one, and it worked fairly well. It produced about 4 or 5 briquettes per minute, and it cost about $20. But there were some annoying features about it. It was difficult to feed the charcoal into the machine, and it also required being cleaned all the time. This little doorway here, there would be a buildup of charcoal, and then you'd have to sweep it out before you could make the next briquette. So what we did was we took a look at what our time was spent on as we were using this prototype. And we found that a lot of time was taking loading the material in, hammering it, ejecting it, and I'm sorry the text isn't so clean there, but the light yellow bar there is the amount of time that was cleaning. So almost half of the time was not making briquettes. It was cleaning out the machine and loading material into the machine. So we came up with a new design, and this is that design right here. It has some features that are an improvement. One is that it's easier to load the material into it. So the loading was much more simple. The next thing, so as you make the briquette, you slide this plate out of the way, and as you slide it, it cleans itself, so you no longer need to be cleaning it, cleaning the press out between briquettes. And in the end, you have a small compacted charcoal briquette. So we were quite pleased with this. This was a prototype that we had made, though, at MIT using the water jet machine. And we thought, well, $30 is a bit expensive. Let's see if we can make that locally with manufacturing techniques, which were not using things like water jets and laser cutters, etc. So we then made it with more local materials, got rid of some of the bigger plates, and made frames by welding angle iron together, and we were able to get down to $20. And we were pretty excited about this. So we went down to Haiti, and we showed people this machine, and they really liked it. You know, we were feeling quite smug. We had gone from $8,000 to $20. We were producing, 6 to 8 strong briquettes that actually burned as well or better than wood charcoal. And so, people loved it, and we said, so, would you buy it? And they're like, oh, no, it's too expensive. $20, come on, man. Anyway, so what did that mean? That meant that we had to really rethink things. So just making it a little bit smaller and using different parts was not going to make the difference. So what we did was we essentially took away everything that wasn't the charcoal briquette forming part of it. And so this is what we came up with. This is actually a square version because it's easier to make than a round version. You just scoop up the material, put it into a support. Sorry, let me move this over. with a hammer and inject it, and there's your briquette. So we're able to reduce the cost by 10 times, and that's a good rule of thumb, which is if you want to make something 10 times cheaper, remove 90% of the material. And the interesting thing about this is that it was much simpler, right? Much easier for one of those roadside mechanics to make something like this rather than something like this. But the really wonderful thing about this is, in actual fact, it's a better machine. Okay, this one actually produces 10 to 12 briquettes per minute, as opposed to this one, which was only 6 to 8, or the previous one, which was 4 to 5. And so one of the things that I think this typifies is that somewhere there is a simple, beautiful, elegant solution that requires a minimum amount of material and yet gives you maximum utility. And I think too often we stop before we reach that point. And so one of the things that I want to leave with you is always continue that quest for simplicity. The next thing I wanted to talk about is dissemination. And this is just sort of a model that we've been thinking about for a particular problem. This is corn. Ironically, I had to bring my own corn to Indiana because we weren't able to get it. But in any case, Mahesh, I'd like to have you come up, and Mahesh and I are going to do a little race here. Yes, that's the plan. Okay, so we're gonna shell the corn right onto here. Okay, and traditionally people store their corn in dried dry on the ears, and when they want to produce their food, they'll remove it by hand. Okay, so and so Mahesh is going to do it by hand, and I'm just going to use this very simple little machine here. All right, ready, get set, go.
Wow.
Okay, so
I still have about 60% left.
That's not bad, actually. Anyway, so
And my hand is not that much better now.
so you feel it.
Yes.
Yeah. So we work in a lot of countries where corn is a staple crop, and you're welcome to stay up if you like, but if you prefer to sit down, you can do that too. But that was the anyway. Thank you, Mahesh. So we work in a lot of countries where corn is a staple crop, and in fact, one of the things we do is in our community technology demonstrations, we bring someone up and we have a competition, and we try to always win, although quite honestly, people there who do this all the time are faster than Mahesh. But in any case, people recognize how wonderful a machine like this would be. It's simple, inexpensive, but a problem is that it's not actually available in a lot of these communities. And so and this device here is made out of plastic. So unless they have an injection molding machine in their village, they're not going to have access to this. So one of the things that we did was we figured out, well, how could we make that out of materials that they do have available? And so so we made devices out of sheet metal instead, and we made a little jig that allows people to take strips of sheet metal and make their own. And the beauty of that is that if they have small corn, they can make a small one. If they have big corn, they can make a big one. So it allows people to adapt things to their own situation. But in some cases, they don't have sheet metal, so we have made them out of just tin cans as well, and these work great. I even use it as a teaching tool. I teach my students how to make injection molded, 3D printed parts. So, so we have students sort of run through the entire gamut of different ways that they can make this corn sheller. But I think that gives us some interesting insights, if you look at the range here, of different ways that things could be disseminated and manufactured. And it's something that we've been thinking about a lot, because we're thinking about how can we take the technologies from D-Lab and scale them up. And something that sort of came to our mind was that if you want to get 1 million things into the field, there's a range, there's a full spectrum of how you could do that. On the one end, you could have one maker that makes 1 million things, and on the other hand, you could have 1 million makers, each making one thing for their own use. And I think an important thing for us to consider in this workshop is where on this spectrum do we lie? What is the appropriate manufacturing model? What are the appropriate materials for this type of model? And to think very carefully about what that means. And it has a lot of implications. So for example, the cost of incremental increases in production is much higher if you have 1 million individual makers, because for each device you want to increase by, you need an additional maker. Whereas if you're making 1 million of these, making 1,000,001 is really just a wink of an eye away. But distribution costs are much easier. If I've made it, then I have it. As opposed to if I'm making this in a factory in the capital, it needs to get to the users. So distribution costs come into play. The local capacity that comes from training people to be manufacturers is much greater than a centralized facility, but quality assurance is much higher if you have control over all of the manufacturing processes. So these are some things that I think are interesting to look at, that are exemplified by this technology, but that are relevant to every type of technology. And so this maker model is something that I would ask us to consider as we're going through our thought processes and discussion groups over the next couple of days. The last project I want to talk about is one that has to do with development. And it has to do with a program that I started in 2007 called the International Development Design Summit. And the idea was to bring, similar to what we have here, bring people from many different countries together to work on creating innovations. And in this particular case, we had 50 people from 20 countries. We had 10 projects, 5 workshops. People were there for 4 weeks, and we made a whole bunch of things, and it was great. But one of the things that came out of this that I realized was far more important was the effect that it had on the people who came there. Not everybody came as designers. We had bicycle mechanics, we had doctors, we had lawyers, we had masons, we had pastors, we had physicists, because innovation happens at the intersections of disciplines. So we brought people from all different disciplines, and what we wanted to do, though, was to train them all to be designers. And so I'll tell you the story of one of them in particular, which is actually a story of 2 of them. Carlos Mahan comes from Guatemala, and he lives and runs a workshop that produces pedal-powered equipment. And this is Bernard Cuilla, who is a bicycle mechanic. And they met at IDDS. And Carlos had made a lot of different agricultural equipment, such as here is showing a rope pump that was bicycle-powered. This is a blender that ladies use to make shampoo at a micro-enterprise. And this is a corn shelling device and a grain mill, which are run by pedal power. This is what Bernard had at his bicycle shop. He would get containers full of broken down bicycles, and he would fix them up, repair them, sell them to raise money for the orphanage where he worked. So when Bernard met Carlos, you could imagine that there was some good synergies there. And when a student of mine went to visit Bernard just 3 months later, they saw that Bernard had made his own pedal-powered pump, but this is a different design than the one that Carlos had made. But he had made one with parts that he could find there in Tanzania. He built a windmill. He and the guys liked listening to the radio in the workshop, but they got sick of buying batteries all the time. So it's a little bit hard to see, but this is also a bicycle-centric device. And if you look at the very top, there's a bicycle wheel and a hub in the middle of the windmill, and then he just built everything else that turned it into a power generation device. This was one of the most wonderful things that he made, and this video also shows another product that he had made, which I hope is going to work. Yeah. So this is a pedal-powered hacksaw. Which is pretty remarkable. This one actually has the top sprocket there can be hooked up to a drill. It can be a drill press, and that gave him the idea of coming up with another drill press. You can see the sprocket that's being used to raise and lower the table, and then you can just come up to this drill press, sit and pedal, and drill holes. This is a person who was not an inventor. When he came to IDDS, he was a bicycle mechanic, and in fact, Bernard would say, I used to fix bikes, now I make things. And I think that's one of the very key things about IDDS was that we created a creator, right? That with a little bit of training and background, Bernard became an absolutely amazing inventor. And in fact, Bernard comes to MIT every year now as a designer in residence, and he consults with our students. And it's amazing what a bicycle mechanic from Tanzania with just a junior high school level education can teach MIT students. This is a cell phone charger that he's designed and is now being sold in Tanzania. It uses it uses bicycle spokes and a little motor from a cassette player, and it clips onto the side of a bicycle, and you can use it to charge your cell phone. So I think that, you know, there's a great importance in the making makers. So there's a variety of things that I think that we should be thinking about today and tomorrow. What is our role as technologists, designers, and researchers, and what are the models along that maker model spectrum that will maximize the impact? What are things that we can learn from previous development? One of the things that we don't want to do is propagate models that will just keep people who are at the bottom of the pyramid firmly entrenched there. I think we need to understand what extreme affordability really is. How can our research promote local innovation rather than stifle it? How do we best engage those BOP communities so that there's mutual learning and growth? And how do we view people in poverty as not as recipients of charity, which is sort of traditional models? Now with these market-based approaches, people view them as customers, but I think it's important for us to view them as creators, and I think Anil's work is very much on par with that. And so one of the things that I think is great is that we have right now an opportunity to work together to explore this in a whole new area, which is the idea of the area of research. Right? Looking at research in materials and mechanics. This is a tremendous opportunity, and I am very grateful to ASME, IEEE, and Engineering for Change, as well as NSF and Ball State, for bringing us together so that we can do this. And I love this quote by Thomas Edison, which is, you know, opportunity is missed by most people because it is dressed in overalls and looks like work. We have an opportunity here, and it should look like work, and I hope we take advantage of it and do great things. Thank you.
Thank you, Amy, for a tremendously inspiring talk. Certainly there's a lot for us to be talking, or will be talking about in the next couple of days with the great thoughts and ideas that you guys have all presented. I was told that we can go a little bit over our allotted time of 11 o'clock, so that's a good thing. I'd also like to ask anyone who may have a question for any of the speakers to bring them over to the side there. There's Yana should be over there somewhere, collecting some of the questions. Amy, your work with students, you work with students all the time, which is a great thing. And the Wall Street Journal earlier this week had published a survey, a happiness survey. And the happiness survey said that for individuals 18 to 29 years of age, what makes them overjoyed is helping others in need. So I think that's kind of very relevant to this whole idea of what we're talking about. And in fact, it is the most important thing in their lives. Talking to young engineers all the time, I can certainly vouch for that, and I'm sure that you can too. Why don't you talk to us a little bit about your students and what drives them and what inspires them about this work? Sure,
and I'm actually, well, I will say to start with is that I think that this generation truly does believe that that is a source of great happiness, fulfillment, and I think that just because information is so much more available, they're both better able to know what some of the problems are and better able to see themselves in a role as solving that. And then in terms of students, the thing which I find phenomenal is the degree to which they are sort of captured by, when they start working on these projects, how they decide that they want to make it their life. And you know, I have a student who is currently the CEO of a company in Tanzania. She's working with Bernard to create these pedal-powered solutions. Another former student of mine is sitting right here, Amos Winter, who is doing phenomenal things with wheelchair design, and he's taught that wheelchair class at MIT, going from a graduate student who was interested in designing things to becoming an instructor of a class, sharing his knowledge with other students at MIT, and now he's in India scaling up the project, and if all goes well, he'll be back at MIT continuing to inspire students. And I think that story is not the exception, it's the rule. People are trying to find a way how they can get engaged and involved in doing this more. And I think that as we expand opportunities, both from entrepreneurial opportunities to now academic opportunities, right? Where if there are significant research programs in this area, then students will find opportunities to go into it as graduate students, as young professors, as researchers at other labs outside, working in companies to produce products for the base of the pyramid customers. And I think it's a tremendous opportunity, and this generation is, they are thirsty for it. And so I think that there's a great opportunity to combine those two things and make a significant change.
Yeah, and it obviously is also, given our emphasis on STEM education, it's a great way to motivate even younger kids to get into engineering and architecture and technical fields.
Yeah, and I think that we have inordinately high numbers of women students in the development-related classes, and so it's been shown that women and minority students are particularly engaged in this type of product, which is, I know, one of the focuses of NSF and other organizations.
Right. I don't mean to put you on the spot, but would you like to comment on any of this conversation?
Oh, I completely agree.
He completely agrees.
I really like Amy's maker model as well. I think there's tremendous opportunity to scale beyond just these low-cost technologies, but there's a range of technologies that are appropriate in these contexts. I just actually drew a figure that I want to use in a presentation in the future. Scaling from 10 to the 0 all the way up to 10 to the 4, 10 to the $5, right? And for different segments of the market, those levels of technologies are appropriate. If there's something like the charcoal press, which is 10 to the $0, all the way up to GE's ultrasound machine, which is 15,000, but was still a grand slam in the Chinese market and also the world market. So I think there's amazing opportunity for tech-focused research in this realm, and it spreads such a big breadth of technologies and money and yeah, just amazing opportunity.
Thank you.
Yeah.
So you're all doing this tremendous work, and the notion, let's talk about the notion of extreme affordability, which was in your last comments, and you've all sort of alluded to it in one way or the other. And the extreme affordability has been defined by even people who sit on the same side of an argument differently. So I'll give you one definition, and I'd like you to refine this definition or give me your own. The definition that I have is extreme affordability refers to the ability of vast numbers of people at the base of the pyramid, a term which I'm not always comfortable with, to gain access to the right materials and manufacturing innovations in science, engineering, and design. How does that sound? How does that resonate with each of you? Larry?
I knew you were going to do that.
Well, you're closer to me.
It's actually, as said in the presentation, really complicated at the scale of architecture. One of the things that we've looked at in terms of our proposal for multi-story units, it would be much easier if we remained on the ground, so to speak, let's say in a traditional indigenous village context. One of the big questions that we've at least proposed and we've assumed right now is that we need to have higher density because of increased population and efficiency, so we don't spread already these sprawling cities out further, but we can densify. But when we do that, and this is where architecture is very different than product design, the scale of the object becomes so much more complicated, particularly structurally. So if we start stacking living units, assuming that we think we need to stack living units, there's a certain level of engineering and structural knowledge that's needed that has not evolved normally within most traditional cultures, so to speak. So there's an inherent conflict, and you'll notice in the scheme that I showed, if you picked up on that idea of the multi-story frame, which is more of an engineering product, versus the, let's say, the hut or the living unit, is of a scale that we can empower persons to help themselves by local materials and maybe craft and technique. So that's part of the complexity I see at the scale of architecture, is how do you deal with, let's say, urban context with indigenous or traditional understandings of how you make a living unit. And I think that's where the hybrid we're trying to interface.
Yeah.
And it's complicated. So I don't know if I answered your questions. I probably didn't.
Well, the issue of scalability, hopefully we'll get to if we have time. But it's a very important point. Anil, extreme affordability.
I would say that affordability is a function of frugality, in as much as a function of its own inherent cost and availability of materials. It also blends individual versus shared inventories. Extreme affordability invariably will require tools, techniques, and manufacturing facilities which are shared. Not everybody can afford to have all the tools and need not have. Extreme affordability also requires blending local and external materials. So we need to create common tool rooms, common fabrication labs, common facilities as much as possible so that people can pool their individual imaginations and create products which are affordable. Extreme affordability also requires flexibility, resilience, diversity, multifunctionality, and renewability. That means different components can last longer and for different applications even after the main product has finished its life. So to me, extreme affordability is a much more richer concept than just providing a solution to the poor people.
A longer life cycle.
Yes.
Amy?
Going back to your definition, I think you put a spin on it that was very technology and science focused, and I don't think that that is the case. I think that affordability is relevant in any aspect of a poor person's life, because when it comes down to it, they're poor because they don't have enough money and they're having to make trade-offs all the time. So extreme affordability is something that a person needs or wants in a way that they can, with their limited resources, access it. And that doesn't necessarily mean that it's inexpensive, because it may be through clever financing models someone can have access to it, or it might be because of the way that a community system is set up. People can have access to a service as opposed to necessarily affording the device. But I think that in a nutshell, it has to do with the availability and accessibility of the technology or the product to poor people.
Right. Sort of a second part to that same question. No matter how we define extreme affordability, I think that we can probably agree that in countries that are at the top of the proverbial pyramid, these issues have not had major consideration or as much as the others. So in these countries, research is normally focused on breakthrough technologies. Do we need to change the mindset of countries like the United States to begin taking a more systematic approach to researching, to do research, and even educational infrastructure in this area? Anil?
I think there is a need for us to realize that if you provide products for extreme affordability, you also increase purchasing power. And it becomes the engine of economic growth. More people can then afford to buy things at the next level, ladder. So extreme affordability to me is a stepping stone for expanding markets. And there is no doubt that the current junk-based, waste-based manufacturing system that is prevalent in the developed countries like US has lived its life. We don't have enough space on this earth if India and China start junking the products the way US does. There is not enough space. So I think we need to change what we are doing in India and China, but we also need to change what US is doing. And it will make the life of people better and safer and healthier and more full of affection and love if they do that.
Larry, how do you feel about this?
Larry? Yeah.
The point of the question again?
The point of the question is, do we need to have a mind shift in the United States to be more cognizant of this notion of extreme affordability?
Yes, and I think that's already evolving. We have the lead system here in terms of energy efficiency, but I think the idea of holistic design, life cycle, is evolving in the marketplace. So everyone claims to be green now, but I think the area is really ripe for research in terms of, one of the interesting things I was picking up on his idea of components that can be recycled. I think in architecture particularly, if you can look at subcomponents, and say it's part of what we're trying to develop is the idea of sub-modules and modules of parts of a building system, I could see that being something that would actually evolve in the building industry. But to my knowledge, there hasn't been a lot of thinking about subcomponents recycling. We used to think about material recycling. But I think that would be a rich area for research and looking at different types of life cycle reuse. And so,
So a better understanding of the nuances of specific projects and opportunities is one way to sort of open up the mindset of countries like you.
and I think that will evolve with the idea of thinking about architecture more as sub-products, which again we could transfer these ideas from mechanical engineering and stuff into architecture.
Right.
If we think about subcomponents, whereby we can reuse maybe them as subunits, which is very interesting. I had not really thought about that. But I think that's a whole mindset that at least I'm not familiar with, that I think would be a really interesting thing to try to look at. But it would take some sophisticated collaboration and work to do that.
Could I just ask him a small question?
Please.
Don't you think it will also require rethinking the very model of paradigm of aesthetics?
Yes.
Because if you don't have to have common handles on each door, and if the handle of a coffee jug, which has lived its life, can be taken out and put as the handle of the door,
yes,
you have to accept that different doors can have different handles.
Yes.
So you need to change the aesthetics as well.
Yes, yes. In other words, of course, that was one of the big failures of modern architecture, is uniformity and everything's the same color and stuff. So absolutely. So we would see, I could envision, let's say if one of these modular kind of units is successful, that there are going to be different colors and different aspects. And I mentioned in the presentation about the Bedouin 10 entry. I would love to see those be hand painted or different colors for personalization of the living unit. And the same way with, and of course the whole aesthetic would change because these ideas of recycled components would be natural to the system. So yes, I agree.
So getting back to that same question, I'm particularly interested in your observations, Amy, since you straddle the educational area and you're also on the ground. But in answering the question, bringing in the element of countries like, I have a friend who works at an NGO in Bolivia, for example, and I know that in India there's a more structured educational effort towards the space, and it's in India as well. How do we do it in the United States if you agree that there's a need to do it? Obviously, I think you would.
Yeah, I actually find it a very interesting conversation, and I have a difficult time answering because fundamentally I believe that we really should be focusing on increasing the capacity in these resource-poor areas so that that's where the creation and the manufacturing and the design is taking place. And yet, I live in the United States, and I enjoy doing this work. I think that for the work to be done best, though, it's done in through co-creation, and therefore there needs to be this common language of design. And so I guess that one of the things that I think is important in terms of education is the education of our students to be able to speak the common language of the village or the urban slum, or to understand that context, and then on the other hand to increase the capacity of the folks living in those areas to be able to speak the language of design, the language of technology, the language of science. So there's sort of two types of education that has to happen. I don't actually believe that changing it so that all the solutions come from the United States, even if we solve all the problems and we have every technology in the world to provide for all the issues, that having it come from here and be delivered to people around the world is not going to be a long-term sustainable solution. And so I think that unless we're looking at increasing the capacity locally, whether that's on the village level, the country level, or the regional level, that fundamentally that has to happen at the same time. So. And that being said, we are here. So, but I do think that that's sort of this almost paradox, which is how do we make differences here? And I do think I was pleased that materials is one of the areas of focus of this workshop, because I do think that when you have new materials, all of a sudden you can have amazing new products. And so, and that becomes a tool that designers everywhere can use. And I think that that's going to be one of the things that changes the way a lot of solutions to the developing world can be, is that there will be innovations in materials that enable all sorts of interesting new technologies. And so maybe that's where the type of research here is happening, is to create tools that allow innovators overseas to be able to create solutions for their problems.
it makes sense. To take it a step even further, the notion of, well, there is a more structured educational system in countries like India and Bolivia, as Shaker and others have pointed out, that they've sort of grown up in it. So there's a need by the citizenry to get involved in these areas, so therefore you need to teach it. How do we, to what extent do we translate that mindset to countries like the United States where there is no need? How do you raise the awareness for the need to engage in developing this sort of technology? Anil, so you're nodding your head.
I would think that if the platforms like Engineers for Change or platforms as NSF and ASME meeting has generated here can become an ongoing engagement. We can have a multimedia, multi-language, online collaborative platform, multimedia, multi-language, so that you can work, you can work with one of these innovators and discuss with him the structures that you were talking about in housing or the way that you talked about design. And this, without their having to come to MIT or having to come to your place, they can benefit from your knowledge and experience. And you might learn something from them, they would learn something from them. So I think it is a case where we treat them as collegial partners in this pursuit. And multimedia, multi-language platform means that they can talk and express their views in Hindi, Tamil or Swahili or whichever language. And there will be need for volunteers who will translate it and make it available in English for you to work with. So we need a global engagement. You talked about consortium, you talked about IDDS, we talked about this platform. I think there's a common feeling. We are using different words, different ways of saying the same thing, but there is a realization all of us have that there is a huge need for engagement of formally trained minds for such a long time, which have remained insulated from the creativity at grassroots, and the mind at the grassroots, which have remained aloof and insulated from the knowledge and science that we have produced, both of them to engage.
Yeah. Anyone else want to comment from the panel on this?
I think in a way what we're talking about is push-pull. I'm throwing out some ideas from my perspective, from a U.S. perspective, trying to be sensitive in that context, and we're talking about pulling handcraft and knowledge, so somehow that's the gap.
Yeah.
And that's where the research in a global consortium could be respectful and learn and share in both directions.
Yeah.
Would be the key.
Yeah. Well, I see by the clock on the wall that we are running out of time. Not that, so let's sort of try to, I'd like to have some concluding sort of thoughts. Not that this is a conclusion of any sort, but sort of based on the conversation and sort of bringing it back to why we're here for this NSF conference. Clearly, what we've heard is that the base of the pyramid markets are vast and they're underserved and probably underexplored to some extent, especially from the perspective of cutting-edge technology research. So I think we've identified that there are a number of challenges here, and that we need some savvy solutions, whether they're technology solutions or architectural solutions. So one of the primary challenges appears to be better educate ourselves in this country about how to do it. Any final thoughts or comments from each one of you, Larry?
It's a complex situation, and I think the key thing is, of course, knowledge sharing in a global context. We've all talked about acting locally, but I think the key thing that I would perceive is how do you, let's say in terms of commercialization. Some areas you're looking at volunteer work or local kind of craft.
Right.
For me, let's say from my perspective at the scale of architecture, the complexity is, of course, scale of the objects, structural issues, life safety issues, which is part of what makes architecture so complicated. And how do you share knowledge across the idea from an individual who can maybe work on their personal home scale into a system that's a multi-story that has other life safety codes. So I think somehow that probably is a unique design problem that needs some type of research environment. So it has to spring somehow, to me, between research, private sector commercialization, and partnering somehow in terms of knowledge sharing, and even down into the community. And that's a complex model. I think it's going to be initially pushed with research, collaboration and research.
Do you agree with that, Anil?
Yes, and I thought what Amy's example of making that briquette was an interesting one, because when she came to the simpler design, the productivity went up actually, and material went down. So it was very interesting that the hand, which were, for 50,000 years, we were using hand as tools in the evolutionary history. And we went to complete automation, thinking that that was the best way. But under certain conditions, I think your example was showing that if you bring hand as a tool back into the manufacturing process, actually your productivity goes up instead of automated system. So the idea that for flexible manufacturing at local level with certain kinds of materials, hand as a tool need not be taken out of the framework of thinking and designing is a good one, is a useful one. And perhaps that is an insight which I thought was very powerful, and we need to really build upon it. So our students need to be taught in different ways. They need to be taught about the advantage of using flexible manufacturing systems which need not be completely automated to be more effective and to be more efficient. This notion, I think, is very useful.
I would build on that we're here used to sort of trying to reduce human labor, and yet in a lot of these countries there's 60% unemployment, and so if you're doing things to take even further labor away from people, that's not benefiting their economic situation. And so one of the things that I would say is really understanding the user situation, which is, I mean, any good designer does user-centered design, understands the context, not just of the individual, but the surrounding area. And I think that that's important, and that's one of the things that has to, that we have to augment in our education. And then another thing I'd like to just follow up to build on something that Anil referred to is this idea of taking waste streams and using them to as inputs to systems. So whether it be agricultural waste turning into charcoal, or whether it be coffee handles on doors, or I just think we are a culture that produces a lot of waste, and it's not sustainable if it just remains waste. So encouraging the idea of how can you take waste streams and turn them into profit streams is something that I think is an important area to be looking into.
Yeah, absolutely. Well, for those of us here, the conversation is just beginning. The next couple of days will be hopefully very fruitful. For those of you online, I invite you to come back to us for our 2020 presentations, which I think you'll find most interesting. I'd like to invite the folks here that are attendees to come outside for an exhibit, and then we're going to be off to lunch. And for everyone, I just thank you all for your participation, for your interest in this area, and certainly for your dedication in helping to make this a better world for everyone. So thank you for joining us.